this video, we're going to talk about how you can use logarithms to solve exponential equations. So remember, you can undo an exponent with a logarithm. So suppose you want to solve the equation 2 to the x equals 55 for x. You can solve for x by actually taking the logarithm of both sides. So when we first began discussing logarithms, we said that this was the whole entire purpose of logs, right? Was to be able to solve exponential equations. So notice here we have an unknown exponent. So what we can actually do is go ahead and take the common log of both sides. So when you take the common log of both sides, we end up with something like the log of 2 to the x equals a log of 55. Then we need to be able to solve for x, and that's going to require us to use a few more steps, and that's exactly what we're going to be talking about in this video. So first we need to use something that's very useful called the power property, okay? So logarithms have this special property that will allow us to solve these equations. So what happens is if we're taking the log of something that's being raised to a power, we can bring that power down in front and turn that into a coefficient. So the log base b of m to the r is going to turn into r times the log base b of m. Okay, so keep in mind that this works with a log of any base. So for example, if we have the log, so that is the common log, right? The common log of 5 to the x, we can go ahead and rewrite that as x log 5, right? So that x is going to come down in front and become a coefficient. If we have the natural log of x cubed, that 3 can come down in front, and that's going to become 3 natural log of x. So let's go ahead now and put all these steps together and use logarithms to solve exponential equations. So we always need to first start off by isolating the term with a variable. Okay, so we're going to get that exponential term by itself, and then we're going to take the common or natural log of both sides of the equation depending on the base. Then we're going to solve for the variable if needed. So let's try solving this equation. We have 4 to the x equals 11. So the base of this equation is 4, so I'm going to undo it using the common log, okay? So I'm going to take the common log of both sides. I have the log of 4 to the x equals the log of 11, okay? So when I do this, that power property is now going to allow me to bring this x down in front. So I have x log 4 equals log of 11, okay? So now I need to solve for x. Well, if you think about it, the log of 4 is really just a number, right? So if I go to my calculator here and if I type log 4, it gives me a value that's equal to log of 4. So if I have x being multiplied by a number, remember the way to isolate x is to actually go ahead and divide both sides by whatever that number is. Okay, so in this case, that's a log of 4, so I'm going to go ahead and divide both sides by the log of 4. So this is going to lead to this log 4 canceling on the left, so I have x is equal to the log of 11 divided by the log of 4. Okay, so this is what's known as the exact value of x, because I haven't approximated or rounded anything. But if I want to approximate the value of x, I can go ahead and type this in my calculator. So I can do log of 11 and then divided by log of 4. And that's going to give me this value. I can round to 4 decimal places. So I have 1.7297. Okay, and that is approximately the value of x. So now let's try solving this equation. We have 7 to the 9x equals 5. Once again, I'm going to go ahead and take the common log of both sides. So I have 7 to the 9x equals the log of 5, right? So that 9x, that exponent can come down in front, and that's going to become 9x log of 7 is equal to the log of 5. So now let's think about how would we go about solving for x. So if we look at this, see that x is being multiplied by two numbers, right? It's being multiplied by 9, and it's also being multiplied by the log of 7. So in order to isolate x, I need to divide by 9 and I need to divide by the log of 7. And I can do this in one step if I divide both sides of my equation by 9 log 7. Okay, so now the 9's will cancel, log 7 will cancel. So I have x is equal to the log of 5 divided by 9 log 7. Okay, and what I can do now is I can approximate this value using my calculator. I'm just going to go ahead and do log 5 divided by 9 log 7. Okay, and so we can go ahead and round this now. We have 0.0919. Okay, so that's going to be rounded to 4 decimal places there. So now you can go ahead and pause the video and try doing this example on your own. So when you solve this problem, you're going to start off by taking the log of both sides. So we have the log of 3 to the x equals the log of 16. Then you can bring that exponent of x down in front. So you have x log 3 equals the log of 16. And then we can solve for x by dividing both sides by the log of 3. When we do this on our calculator, we have log of 16 divided by log of 3. And that's going to give us approximately 2.5237. So now let's go ahead and solve this problem. So here you can see I have an exponential term that's not isolated, right? Because it has that 2 in front of it. Since that 2 is multiplying this exponential term, my first step is actually going to be to go ahead and divide both sides by 2 so I can get that 5 to the x by itself. So here you can see the 2's will cancel, so I have 5 to the x equals 30 divided by 2, which is 15. So now I need to solve 5 to the x equals 15, which I can do by going ahead and taking the log of both sides. So I'm going to take the log of both sides. And so what I can do now is once again use the power property and bring the x in front. So I have x log of 5 equals log of 15. And now what I can do is solve for x by dividing both sides by the log of 5. When I divide both sides by the log of 5, that's going to give me x by itself. So I have x equals log 15 over log 5. And I can now approximate this with my calculator, right? I just go over here and I'm going to do log of 15 divided by log 5. And that gives me my value that I can approximate to 4 decimal places, right? So I have 1.6826, and that is approximately the value of x. So now you can go ahead and pause the video and try doing this similar example on your own. So here we have 4 times 5 to the x equals 52. So you can solve by dividing first sides by 4. So that gives us 5 to the x equals 13. And now we take the log of both sides. So we have x coming down in front also. So we have x log 5 equals log of 13. We divide both sides by the log of 5. And then you can do the log of 13 divided by the log of 5 on your calculator, which gives you approximately 1.5937. So now let's try solving this equation. Here, notice that my base of my exponential term is actually e, okay? So whenever the base is e, you want to use the natural log, okay? And you're going to see why as we work through this problem. It's a better idea to use the natural log on this problem because when we go ahead and take the natural log of both sides, something very interesting will happen here. So as usual, we can use our power property to go ahead and bring the 4x down in front, right? So we have 4x times the natural log of e is equal to the natural log of 5, okay? Let's think about what the natural log of e is, okay? If we do natural log of e, okay, and if you want to actually try this on your calculator, you can do that. You can do natural log e, and it tells you that's equal to 1, okay? Let's think about why is this equal to 1? The natural log of e is equal to 1 because the natural log is actually the log base e, right? So we're saying what is the log base e of e? Why is that equal to 1? The reason it's equal to 1 is because remember, if we rewrite this in exponential form, that's saying e to the 1 is equal to e, right? And we know that's a fact. If you want to raise a number to a power and get that same number as a result, that power has to be 1, okay? So anytime you're taking the log of something that's equal to the base of the log, that's always going to reduce to 1, okay? So this natural log of e is just basically going to be 1. So this is like basically saying 4x times 1 is equal to the natural log of 5. Well, that's basically saying 4x is equal to the natural log of 5, right? So now to solve for x, all I need to do is divide both sides by 4. So I get x equals the natural log of 5 over 4. Okay, so it's going to simplify like that, and that's why it's a better idea to use the natural log when you're working with exponential equations that have a base of e. So if I do this on my calculator, now I'm going to type natural log, okay, and then do natural log 5 divided by 4. And so that's going to give me x is approximately equal to 0.4024. Okay, so now let's try this problem. Well, here I have a base of e in my exponential term, but notice my exponential term's not isolated, right? It's not isolated because I have this 3 and I have this plus 1. So I'm going to start off by subtracting 1 from both sides. And when I do that, I get 3e to the 2x is equal to 25 minus 1, which is 24. Now I need to go ahead and divide both sides by 3. So that's going to give me e to the 2x is equal to 24 over 3, which is 8. Okay, now I have an exponential term that's isolated and the base is e, so I'm going to take the natural log of both sides. So I have the natural log of e to the 2x equals the natural log of 8. And I can go ahead now and bring this 2x down in front. So I have 2x natural log of e is equal to the natural log of 8. Since this natural log of e is equal to 1, I can say 2x equals the natural log of 8. Okay, now to solve for x, I'm going to go ahead and divide both sides by 2. So I have x equals natural log of 8 over 2. And I can go ahead now and figure this out on my calculator. I'm going to do natural log of 8 and then divide by 2. And that's going to give me x is approximately equal to 1.0397. Okay, and that is the approximate value of x. So now you can go ahead and pause the video and try doing this example on your own. Here, once again, my exponential term is not isolated, so I'm going to go ahead and add 2 to both sides. So I have e to the 3x equals 7. Now, once again, I need to take the natural log because my base is e. So I have natural log of e to the 3x equals natural log 7. The 3x comes down in front, so I have 3x natural log e equals natural log 7. And then that's going to reduce to 3x equals natural log 7, and I can divide both sides by 3 to get x is approximately 0.6486. So remember, you can solve an exponential equation using common logs and natural logs. You want to always first isolate the term with the variable and then take the common or natural log of both sides of the equation. Then you can solve for the variable.